Guys, welcome back to TechDose, and in this video we will see make sum divisible by p problem, which is from Leetcode number 1590. You can consider watching the video on subarray sum equals k, which is from Leetcode number 560, and the perfect subarray problem from Google Kickstart 2020 round C question 3. I have already made videos on both of them. You can click on the I button or also check out the description section to go and watch this video. Let's now look at the problem statement. In this problem, given an array of positive integer nums, we need to remove the smallest subarray such that the sum of the remaining elements is divisible by p. It is not allowed to remove the whole array. Return the length of the smallest subarray that you need to remove, or -1 if it is impossible. A subarray is defined as a contiguous block of elements in an array. Okay. Now, if you look at the constraint section, then it says that you have 10 to the power of 5 elements. That means order of n square algorithm will not pass here because that will be 10 to the power of 10. We need something less than 10 to the power of 8. Okay. Now, if you look at the number of items, it was 10 to the power of 5. Each item size is 10 to the power of 9. So, one sum value can be equals to 10 to the power of 9 into 10 to the power of 5 if you add up all the values, right? And in that case it can reach to 10 to the power of 14. So 32-bit integer will not be able to hold this number. You need to take 64-bit integer. Okay, let's now look at an example for better understanding. Let's say that our given array is 6352. In this case, if our p value is equals to 9, that means the divisor is 9, then what will be the minimum size subarray if you remove, so that the rest of the array will have sum divisible by p? In this case, the answer is equals to 5,2. Because you cannot remove any subarray which is smaller than 2 size, so that you make the rest of the array sum divisible by p. Okay. Now the goal is to remove the smallest subarray to make sum mod p equals to 0. Let's look at another example. If you have 3432, then again if the p value is 6, then we need to return the size of the smallest subarray that you can remove, so that the rest of the array sum will be divisible by p. Okay, in that case you can just find out the 3, remove it, and then the rest of the array sum will be divisible by p. How to find this? One simple approach can be to try for all possible subarrays, like subarray starting with index 0. So you will have n such subarrays. Subarray starting with index 1, you will have n minus 1 such subarrays, and so on. So you will have order of n square such subarrays, right? And we know that we cannot solve this problem in n square time complexity, so I will not be going to do that anyway. Now let's look at the third example. In this case, our array elements are 13, 7, 3, and our divisor is 6. Can we remove some items here, 0 or more items, so that the rest of the array sum will be divisible by p? I think we cannot do that. You can try it out, and so we will return -1 in this case. So I hope you have understood the problem statement. Now I will take the inspiration from the subarray sum equals k problem. Okay. Now let's say that our goal is to find the subarray with the sum value equals to 0. Okay, and I have given the cumulative sum, that is the prefix sum of the given array. So in the prefix sum, when I say this x, it is the sum from the beginning till index I. And when I say this x at index j, then this is the sum from the beginning till index j. So what will be the sum in between? If we have seen the same sum 2 times, then definitely in between the sum must be equals to 0, right? So the subarray size which will have sum equals to 0 is equals to j minus I. Okay. Now if we are given this array, okay, 3 minus 2, 1, 3 minus 4 and 1, then if I try calculating the prefix sum, why will I calculate the prefix sum? Because I wanted to find out the subarray size, the smallest subarray with sum equals to 0. Let's say I just want to find out the subarray sum equals to 0, right? So if you look at the prefix sum, the numbers repeating are this 1, and then you can look at this 2. Right, so if 1 is repeating, then definitely in between the sum must be equals to 0, and if 2 is repeating, definitely in between the sum must be equals to 0, right? So that is how you can identify the subarrays with sum equals to 0. Okay. Otherwise, if the sum from the beginning is 0 at any current point, then right from the beginning till this index, let's say index 5, your sum is 0. So these are the two cases where I can say that the given sum is equals to 0 in a subarray, right? So why I am explaining all this? Because this will be used in the current problem solution. Now let's look at another goal. Let's say that I want to find out the smallest subarray with sum equals to 0, and let's say I have seen x 3 times. Then what will be the size of smallest subarray? Now if you visually try to solve this, then the first subarray will be from 1 to 12, which is of size let's say 11. Then one of the subarrays will be from let's say 8 to 12, which is of size 4, and another subarray will be 1 to 8, which is of size 7. Out of this you can track the minimum one and the answer will be 4, right? But how to do this tracking? Well, you can use a map where the prefix sum will be in the key portion and the index will be in the value portion, and you try to solve this entire parsing from one side, that means from left to right. So if you see an x, you just remember at what index have you seen that. Now if you see this x again, you have to check it in the map. Have you seen this earlier? If you have seen this earlier, the difference in the index 8 minus 1 will give you the minimum length or the minimum size. So let's say the minimum size was infinity and now it becomes 8 minus 1, so this will be 7. And again overwrite this with the new index 8. Okay, why are we overwriting? So that we always remember the latest x, because if I happen to see this x again, then if I want to minimize the subarray size, then definitely I will just be calculating from the rightmost already seen same sum value rather than looking at one, right? 8 will be useful. So that is why I am just overwriting it. If you see this x again at index 12, then definitely I had already seen it at 8. So what will be the gap? It will be 12 minus 8, which is 4. So 4 is smaller, so I will just update it. And that is how you can track the minimum size subarray where sum is equals to given 0 value, right? Now let's see the logic for finding the target sum subarray. In this case, our goal is, let's say, to find the subarray with target sum where the target x is equals to 2. So if my ith index has a value y minus x, which is let's say 8, because I have assumed x to be 2 and y to be 10, and if I have seen y at some point, then in between, what will be the sum? In between, the sum must be equals to x, which is 10 minus 8, right? So if I have already seen this y minus x at some point, which was equals to I, at index I we have seen that, then my target will change from x to y minus x, because if I have already seen this y minus x, then in between the sum will change to what is the sum from the beginning till index j, which is y, and from the beginning till index I, which is y minus x. So if you subtract, you will get the sum value from I plus 1 to j, and that will be equals to x, right? So that is how you can find out the subarray with sum equals to x. Okay, and the subarray size will be j minus I, right? In the similar way, if the goal is to find the minimum size subarray with target sum equals to x, and if you have seen a y and y minus x 2 times, then it is always important to overwrite the value of y minus x whenever you see it again, so that your subarray size is always calculated with the latest index of y minus x, so that it will be always the smallest subarray. Okay, so just think about it, right? Now we will be applying the similar approach to solve this problem as well. In this problem, we will be finding the remainder prefix sum. Okay, what is that? Let me tell you. If you have an array 3, 7, 8, 2, then I will always keep adding the values to the previous item and take mod of p. So let's say the p value is 5 in this case. So initial value is 3. 3 mod of p will be 3 only, right? So I will write 3. Now 3 plus 7 mod of 5 will be equals to how much? It is 0. So I will write a 0. Now 0 plus 8 mod of 5 will be equals to 3. 3 plus 2 mod of 5 will be equals to 0. So this is the prefix sum remainder array. Now once we have done this, you should notice that whenever you see the same remainder value, then your entire array sum in between mod of p will always be 0. So you see this 7 plus 8, 15 mod of 5 will be 0. Similarly, if you see this 0 again, then in between all the array items, if you add and take mod of p, it will always be 0. So this is an important point to note. Okay. Now based on that, let's see what is our goal. So in this case, our array sum will be equals to 37, let's say, and our p value is 5. Then sum mod of p will be equals to 2. Now if it was not 2 but it was already 0, where I have taken another example that array sum is 35, p is 5, then we don't need to remove any subarray, and I can say that without any removal only the entire sum is divisible by the given p value, which is 5, right? So in this case I will return 0. Otherwise, if I have sum mod of p equals to 2, then I need to remove a subarray which should be of smallest size definitely, where the subarray mod of p, the subarray sum mod of p must be equals to 2, and that is how the rest of the array sum will have a remainder 0. Okay. Now if you look at an example here, then in this example you can test it out, right? So in this array there are two candidates which have subarray sum mod of p, that means mod of 5 equals to 1. So in this case 4 plus 2 mod of 5 is 1, and if you look at this 4 5 2, then you add it up, it will be 11. 11 mod of 5 is 1. But then which one is of the smaller size out of these two? So these two are of the smaller size, right? So if you remove it, then the rest of the array sum 3 plus 5 plus 2, which is basically 10, 10 plus 10, 20, mod of p will be 0, right? So the answer in this case will be 2. Okay, so I hope you understood this. So we will be removing the smallest subarray with sum mod p equals to 1. Because why did we find with 1? Because the initial array sum mod of p was equals to 1. So we need to remove this factor. Okay, so I hope you have understood the goal of our problem. Now I have given one example for the impossible case where I have, let's say, 5 5 5 and our p value is 6. Now you cannot remove a subarray in such a way that the rest of the array sum mod of p will be 0, and you should not remove all the items, by the way, right? So if you remove 1 5, the rest of the sum will be 10, not divisible by 6. If you remove 2 items, again 5 is not divisible by 6. So in that case you need to return -1. Okay, now you can also get negative remainders in this case, so we need to adjust the negative remainders. But let me tell you that 37 mod of 5 is equals to 2, so 2 is considered as remainder. What is a positive and negative remainder? Let's say we take the p value equals to 5. Then in case of positive remainder we can have 0 1 2 3 4. But then in case of negative remainder, -1 negative remainder's meaning is 4. That means when I say -1, that means from 5 I want to decrease 1. So if from 5, that means from the p value, if I decrease 1, where will I go? I will go to 4. If -2 remainder means from 5, that means p value, I want to decrease 2. So we will go to p -2, right? So we will go to 3. For -3, I want to go to p -3, which is 2. And similarly, the negative remainders run in the opposite order, right? So I have just shown in a cycle that positive remainders run in 0, 1, 2, 3, 4 format, and the negative remainders are just in the opposite direction. So in order to adjust this, that even though you get a negative remainder, it should be equivalent to some positive remainder, right? So we will be converting negative remainders to positive. So -4 will be adjusted by adding the p value, because if you add a p value, we are going around the circle one time, and effectively if we take mod of p again, then there will be no change, even if the remainder value is positive or negative. So let's say I have a positive remainder value 2. To this, if I add this p value 5 and take mod of 5, it will still be equals to 2. But if I have a negative remainder value, let's say -2, and if I take +5 mod of 5, then it will be equals to 3. Okay, and that is correct. -2 should be equals to 3, right? So this is the adjustment we need to do, right? So I hope you have understood this. Now, having understood all the things, let's do a dry run immediately, and then we will look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. Before doing the dry run, I will just tell you that if you are given an array, and if the remainder for the prefix sum here is 2 and the remainder for the prefix sum here is 3, then in between the subarray sum mod of given p value will always be equals to 1, which is 3 minus 2. Okay, this is according to what we have already seen in the subarray sum. It is true for the remainders as well. Okay, now having known this, let's start our dry run from the first item. Before even doing that, we will maintain a map which will tell us about what all sums we have already seen. So 0 will be inserted by default at index -1, because even if I don't include any item, I will have -1, right? Now our array sum is 26 in this case, and the sum mod of p is equals to 1. If it was 0, then I don't need to do any kind of parsing. I can just say that we don't need to remove any subarray. It is already divisible by p. But since it is 1, which is not 0, that means I need to remove the smallest subarray, where the subarray sum mod of p will be equals to 1. If there is no such subarray, then I will return -1, that is, it is impossible to remove any such subarray. Okay, so I will start at 3 and I will keep my current sum equals to 3. Okay, so this will act like a prefix sum. So when I add this 3, I will always take mod of p, so that my values are always in the range of 0 to p minus 1, that means 0 to 4. Now once you have found this 3, then what will be my target sum? Like I had already explained you that in the subarray sum problem, that if you are seeing a y and if you have already seen a y minus x, and if your target was equals to x, and if the current item being seen is y, then you will try to find out if the target y minus x have already been seen y minus x, so that the subarray sum in between is equals to x. We will apply the exact same logic here as well. So what will be my new target here? So the target remainder will be equals to this current sum minus 1. So current sum minus 1, and since the remainder value can go to negative, that is why we will add the p value to it and take it mod of p. I have already explained this, right? So this is the negative remainder adjustment. So in this case 2 plus 5 mod of 5 will be equals to 2. Okay, so have we seen this 2? We have not seen this 2. Okay, so I mean this is an invalid subarray, so I can just insert this 3 and I have seen this as index 0. Now I will go to the next item and I will update my current sum to 5. Now 5 mod of 5 is equals to 0, so this will be updated to 0. What will be my target remainder? The target remainder is equals to current sum minus this one, so 0 minus 1, and I have to do the negative remainder adjustment, which is plus 5, and take mod of 5, so that will be equals to 4. Okay, so have we seen this 4 already? No, we have not seen this 4. So let's insert this 0, that we have seen a remainder 0 at index equals to 1. Now we will keep proceeding with the dry run. We will see the next item. In this case, this is 4. So the current sum will be adding 4 to it and taking mod of 5, it will remain as 4. Again, we will calculate the target remainder, which will be equals to 4 minus 1, which is 3. Okay, even if you add 3 plus 5 mod of 5, it will still be 3, right? So have we seen 3 already? Yes, we have seen 3 already. Okay, so let's take a min size subarray. So min size subarray, which will be equals to, let's say, I mean infinite length, or maybe the entire size of the subarray. And in this case, when you compare this 3 has already been seen, right? So our target was already seen at 0. That means in between from index 1 to 2, we are seeing at 2 and we have seen already at 0. So in between, the remainder must already be equals to the target remainder, which is 1. Okay, so this is one of the candidate. So what is the size? The current index 2 minus this 0, which is 2. So 2 is smaller. Let's update this to 2. Okay, I think you have understood this. So after that, we will proceed. Okay, before proceeding, definitely we have to make this entry. So we have seen this current sum remainder 4 at index 2. Then if I move to index 5, then we need to just add it to the current sum. So the current sum plus 5 is equals to 9. So this will be 9. 9 mod of 5 will be equals to again 4. Okay, again we are at 4. What is the target that we want to achieve? The target remainder will be equals to the current sum value, that is 4 minus the given target, which is 1. Again you can do the negative remainder adjustment. It will give you 3 as well, right? So have we seen this 3? So yes, we have already seen this 3 at index 0. Fine. So since we have seen this 3 at index 0, that means this subarray is also a candidate. Okay, and what is the size? We are looking at index 3. We have seen the same target remainder at index 0. So the size is 3 here, which is 3 minus 0. But then we have already seen a subarray of size 2. So there will be no update. Before moving forward, we will override this 4 we have seen at index 3 now. 4 remainder. Okay. Now I will go to index number 4. Okay. Now again I will add this 2 to my current sum. So 4 plus 2 will be 6. 6 mod of 5 will be 1. Now our current sum mod of p value is 1. So what is my target remainder now? It will be 1 minus 1. So it will be 0 simply, right? Even if you do the negative remainder adjustment. So have we seen 0? So yes, we have already seen this 0. And we have seen it at index 1, right? So what is the size of the subarray till then? So it is equals to 4 minus 1, which is 3. But then the already known subarray is of lower size, which is 2. So no update will happen. Let's go to the next item. Okay, before going to the next item, definitely I have to make this entry here. So 1 current sum mod of p1 has been seen at index 4. When we go to the next item 5, 10 will be added, so this becomes 11. 11 mod of 5 will be equals to 1. Now again you need to find the target remainder. The target remainder will be 1 minus 1, which is 0. So where have we seen 0? Again we have seen 0 at index 1. So this means the subarray size since then is equals to 4, which is 5 minus 1. But then 2 is smaller, so we do not need to do the update. So this is the entire dry run, and our answer in this case should be 2. Now if you notice, we are going through the entire array exactly one time, and we are maintaining the map where we are doing the entry and lookup in order of one time. Therefore the time complexity will be order of n and the space complexity will be order of 1 for doing the lookup. Let's now look at the code. In this code we are given the nums array and the p value, and I will first find the sum value using the long integer, okay, which is 64-bit integer. Then I will find out if sum mod of p is 0. If it is, then we do not need to remove any sub array, and I will return 0 because we want to minimize the size. Otherwise, if that is not the case, then I will find the target, that means sum mod of p. In our dry run I had shown the target was equals to 1. I will be maintaining a map for the lookup of the already found remainder index, right? And I will do an insertion for remainder 0 with the index minus 1, because if I don't include any item, then 0 can always be formed, right? After that we will be maintaining the current sum and the min size. The min size is equals to the array size. I had taken infinity in the dry run. Now I will be iterating for all the items, and initially I will be adding the current item to my current sum and take mod of p. Then I will be finding the target remainder, which is the diff value here, okay, the target remainder, which is equals to the current sum minus target. And then I am doing the negative remainder adjustment by adding p and take the entire value mod of p. And then we will check if we have already seen the target remainder. If we have seen the target remainder, then I will find out the minimum subarray size, which is the minimum of already known minimum subarray size, comma, the previous time when we had seen this subarray, minus the current index, which is I, right? So I will update the minimum size subarray, and after that I will be putting an entry for the current prefix sum remainder value, okay? And after having done all the iterations, if the min size is still n, that means I could not find even a single subarray, removing which I will get the rest of the sum value equals to 0 when you do mod of p. So in that scenario, I will return minus 1, otherwise I will return the min size. I hope you have understood this. The GitHub link will have the code in Java as well as Python. If you have any doubt, then please comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.